All right, it's 10:30, so I'll get started. Hi, thanks for coming to my talk. I'm Emily. I'm a data scientist at Figma, and I'm very excited to share with all of you a bit about our ML journey on the data science side. All right, so Leo Tolstoy once wrote that all happy families are alike, and based on my conversations with peers, what he really meant is all happy ML pipelines are alike, especially in the first year of pipeline setup. And this talk will get into more about the similarities that you can expect across new ML pipelines. So today I'll be sharing our journey from hacking together V0 of this pipeline to actually shipping models in production, measuring our first wins, and securing longer-term support on both the engineering and product side for our ML platform. And the impact we saw during the first year of this platform work is that we shipped multiple models into production and measured both metrics wins and reporting wins. We made improvements to some pretty foundational parts of the Figma UI. And like I mentioned before, we've gone from kind of like a hacky pipeline to a real data product within Figma. The impact that we saw in this first year really speaks to the timing of our investments, and that's where I'd like to start. So when do you build an ML system? Might seem obvious, but it's when the business needs it. And for us, this happened during what I call the optimization phase. And that's where, on the product side, you start to explore optimizations and heuristics to create a more personalized experience in the product. There are a lot of heuristics lying around Figma, and here I have this Slack message where we're just internally discussing how complicated one of these heuristics has gotten. Another sign that the data team was ready to productionize ML models is that we had some complex heuristics being used on the reporting side. So we're running these heuristics every single day, evaluating their performance on our data and reporting out on heuristic metrics, at which point you might as well consider moving to ML if you think you'll see a performance gain there. Something that's really interesting to me is we reached this state kind of independently of the scale of our business or the data team. So by the time we reached this phase where on the data science side we were ready for ML, Figma had already become a global multi-product business, and our data science team is already pretty large. Okay, now that we've discussed when to build, the next question is how. So when reading blog posts about ML systems, they're often written by a data team that has an entire other team or org supporting their ML use cases. And while it would be really nice to have that on day one, that's very rarely how the story starts. And at Figma, we started with a tiger team of 3. So we had my colleagues, Kelly on the data science side building the model, Aditya on the engineering side building out a product experience as well as helping out on the pipeline, and then I was working on the pipeline work. And from what I understand, it's pretty common to start with a tiger team of 1 to 2 data scientists and engineers because the demand for ML in the early years of building this platform is highly variable. It depends on the needs of the business, and it probably doesn't make sense to immediately staff any ML work with a full team or to immediately purchase a solution. Cool. Moving into some design decisions. So when I was talking to peers and doing some research around ML pipelines, something that I heard is that it's really easy for your pipeline to fail silently, and it doesn't really have to do with the ML side. It really has to do with how you're reading and writing your data, and just bugs in your code that won't cause a pipeline to fail, but will cause the model to degrade in performance. And I've included this graphic from Designing ML Systems by Chip Huyen, which is a great book, And I like it because she's outlined all these different places in your pipeline where it can fail and how hard it is to detect failures in each of these areas. And so given this knowledge that it's really easy for your pipeline to fail silently in ways that you're not familiar with, we picked a design that really focused on predictability and observability. So some of the design decisions we made in V0 of our pipeline are that we reused tools in our data stack. So these were tools that had established data access patterns. We used offline batch prediction. So what this means is like every night we are computing all of our model predictions at the same time and then uploading them to the product. This lets us sidestep any like infra investments we needed to make around serving predictions in real time or serving features to our model in real time. And then we've invested in observability even in V0 of the pipeline. Observability isn't really like a fancy term, or we're not using any fancy tools. What this really means is if our pipeline has run before, we need to understand exactly what happened at every step. Getting into the pipeline details, this is like the tooling that we started with. So of course, this is a DBT conference. So we started with DBT to generate our nightly inference and training data sets for our offline batch prediction. We used Snowflake, where we would snapshot a lot of our data sets and model artifacts to be queried later for observability purposes. We used Dagster, which is just our job orchestrator, which ran our nightly ML job. And then we would upload our results to Amazon S3, where they would get read into the product. In terms of the Dagster job itself, it's a pretty simple one. I don't think the first ML pipeline needs to be too complex. But what you can see is that there is like a training data and an inference data step. So this computes, this like reads some of our features from dbt and does any additional transformations needed in Python. Then we have a trained model step, where we are using the training data to train our model for the day. There's an inference step where we apply our model to our inference data. And then finally, there's like a final result step where we post-process our model results. So maybe we're re-ranking based on model results, or we're only returning the top 5 model results, and then we're uploading that to S3. In terms of our first 2 use cases, here they are. So we focused on ranking and recommendation. And the reason, we can go a little bit more into like the reasons why we focused on those. But our first use case was community recommended resources. So on Figma, we have this product called Community, where people can post like files for others to share, and recommended resources would recommend like related files for users to browse. And the goal there is to get new users more engaged in Figma and hopefully get them to sign up. The second use case we looked into was sharing suggestions. So in Figma, the files all have URLs, and it's a collaborative tool, so we want you to share the files with your peers. And here, instead of kind of a UI that makes you remember like who exactly you need to share the file with, we add suggestions for people who we think you collaborate with frequently. And what these 2 use cases have in common and made them like ideal partners were first that there was pretty clear business impact. And obviously this matters for like business reasons, but something that we found as a platform is like ML is a really hot technology. A lot of people in the company want to use it. A lot of product teams want to use it. But like when push came to shove, the teams that were truly committed in shipping a model and the extended timelines that come with that were the ones where the ML had to do with like the higher level goals of the product team. It's also very helpful to have flexible timelines because we were about to spend a lot of time learning lessons the hard way, and we'll go into that a bit more. And then having simple data freshness requirements is also really helpful. So this is a new pipeline. It can fail, and ideally, like when this pipeline fails, there's not a major regression to the user experience. And so like we're kind of looking at use cases where even if we don't have the most recent day of data, or if the pipeline broke last night, like your collaborators are generally the same day to day, and like related files like maintain the same relationship over time. All right, so let's move into lessons learned. And here they are in our beautiful Figma brand colors. We have data access, version control, dog fooding, and finally patience. OK, so let's start with the first lesson, which is to prototype data access first and machine learning second. So even though we were using the same data that we use for analytics, data access was probably the largest challenge we faced when setting up the model and pipeline. Basically, all of these tools that we had needed different permissions to read or write or interact with our pipeline. And when I think of the way we set up the pipeline and its permissions, the phrase flying the plane while building it comes to mind, and this was incredibly stressful. So here you can see a bunch of messages in PRs. Most of them are from me, just expressing confusion about the state of permissions for a pipeline. So there's a question where I'm asking about Terraform, S3 bucket names, permission grants. There's this message down here that just says, so many permissions, LOL. OK, the first one passed. Now on to the next error. And here's a PR where I got the name of the production environment wrong, and I just needed to fix the string. So it's kind of funny to look back on, but this was really frustrating to work through at the time, because for over a month of building the ML pipeline, different parts of our pipeline would break or be untestable every time we introduced a new data set or promoted the pipeline to a new environment. And our team would be blocked until infra could help us debug or unblock ourselves. And this made it really hard to move quickly and tell if pipeline issues we were seeing were due to the pipeline itself or the infrastructure surrounding it. So this is our first lesson where, looking back, it would have been really helpful to ignore the ML part first and just build a pipeline that had the right data access patterns and was reading and writing the way we expected, and hand that off to infra so those permissions issues could be investigated in parallel with the pipeline. From speaking to peers, I think we actually got very lucky that this took us 1 or 2 months to debug. In many cases, setting up data permissions for your first ML pipeline can take even longer than building the pipeline itself. All right. Second lesson is around observability and validation. So we did have tests for pipeline, but it was still pretty hard to know if the pipeline results were exactly as we expected. All right, so I have 2 mysteries for you. We'll start with part 1, the mystery of the missing files. So we've set up our pipeline. It's running in production. We're super excited, and we hand it off to our product engineer. But for some reason, the front-end code can't find our files. This is the file that we're providing to the front-end code. And I'll give you a few seconds to guess what is happening that's causing the bug. Yeah, we're rounding all of our file keys, and so we're not able to find the files in our front-end code. And it's really hard to debug where this is happening in our pipeline, because we're constantly reading, writing, transforming the data. And we have 2 hypotheses at this point. Either this could happen when we're reading from Snowflake, or pandas could be misunderstanding the types of our file keys. And even more frustratingly, this seems to be happening non-deterministically. So on some pipeline runs, we have the right file keys. On others, we don't. And this was really, really hard to investigate. So what we ended up needing to do is we needed to go into every step of our pipeline and manually look at the data it was producing after we read and write to figure out where in our pipeline this rounding was happening. And so as a result, even in V0 of our pipeline, at every step, we're writing intermediate results to Snowflake or S3 or both. And kind of the lesson here is that storage is cheap and life is a lot better when you're able to query the results from your pipeline. And yeah, we continue to find this really useful, all these snapshots, in order to understand and debug pipeline issues, which we have more of. OK, part 2, the mystery of the missing accuracy. So we've put together pipeline v0, and we're migrating to a new version. And we want to make sure that nothing strange is happening in between the 2 versions. And so something we do is compare the accuracy of our model in pipeline v1 against the accuracy in pipeline v0. And so already we notice a small gap of 62% accuracy in v1, 64% accuracy in v0. And then looking at these numbers, this is a binary classification task. So 60% is not that great for a product use case. And I'm kind of surprised that we would want to be shipping a model with this performance. So then we go back to check on the notebook, and the notebook says it has 81% accuracy. So something is going really horribly wrong here. If you look at the steps that go from, that are involved in like moving from your notebook to your pipeline, there are so many ways that this can go wrong and there can be inaccuracies, and we can jump into that. So on the dataset side, I'm very curious if anyone has like solutions for this, but it's just very easy to like incorrectly migrate your code from Snowflake to dbt. And so if you have like the wrong data set for your model, then of course the performance is going to decline. On the modeling side, your model might have been incorrectly migrated from the notebook to the pipeline. Like in the notebook, it might be like spaghetti code, and in the pipeline, hopefully you've cleaned that up, and it's like in your nice model class, and it's got all the helper functions that we need, but there can be bugs there. On the inference side, there could just be an issue in the pipeline where we're training the model correctly, but we're somehow running inference incorrectly or evaluating the performance of our model incorrectly. And then scariest of all, it's possible that in the time it took you to move your model from notebook to pipeline, the model is just no longer relevant, and the underlying relationship in the data has changed. And so given all of these potential areas of like discrepancy, something that we found really useful is to pin the data set and model in the notebook environment and basically be able to reuse those artifacts on the inference side. And this actually required a pretty significant process change for data scientists, since often we're used to being able to like rerun our notebook, try it on newer data, like report the freshest results. And we're constantly like tweaking our model code. And now we require data science to provide a static copy of their data sets, their training data, their test data, and their modeling code for every version of their model they migrate into the pipeline. And that way we can confirm that the performance in the pipeline matches the performance in the notebook as intended. And having these artifacts is really useful, not just for like debugging our models, but for any time like we update the pipeline, knowing like how these models should perform is helpful, and it's also helpful for like tracking the performance of our model over time as it gets retrained daily and it gets more stale. All right, lesson 3: dog food early and often. All right, so here's a diagram of ML Mountain. We had solved our data access issues. And so we are no longer on the ground. We have our model running in production. We fixed those annoying rounding errors. And getting this up and running felt like summiting a mountain. So I thought when we got at the top, we would enjoy the view of the land of cool, and like we'd move a lot of metrics, and we'd be on top of ML Mountain. But little did I know there was one last obstacle that was quite significant. The model we had was performing well on an offline training metric, but the results didn't really make sense in the product. And so in comes dog fooding, and by dog fooding, I just mean like taking the model, running it on internal users, and getting folks to like give feedback on the model results and identify any issues that there might be in our feature set or any patterns in the model behavior that they think we should change. So here's an example of like a recent model that I'm working on. We have 4 rounds of like feedback. And at every round, we collect like more and more feedback. So it starts with like the internal modeling group, and then we add like product managers, adjacent engineers, and we just scale up like the amount of feedback we get at each round. And this is super helpful to help us figure out like if we need to change our modeling strategy, change our training objective, how we post-process the results, all of those things. And some of the issues we found almost immediately with some of our models are listed here. So the first is related to product considerations. For example, different file types. Maybe like different file types shouldn't be shown together, even if our model results think that like they're relevant to each other. Or like another example is maybe if you experience Figma in English, like we shouldn't be suggesting like Japanese titles to you. And catching those in the UI can change a lot. I think it generally changes like either our training data or how we post-process results. Another challenge that we found is popularity versus diversity. So sometimes your model can learn like the lowest common denominator relationship between like entities. And although that might maximize the offline training metric, that might not be the personalized experience that users are expecting in your product. So one question we got is like, why are the same files recommended on every page? And that's because they're popular. We think that users will click on them, but that's not really in the spirit of like recommending relevant resources. And then a third issue we've caught is model instability. So Figma is like a business tool. People do their work in it. Ideally, like the UI and various surfaces shouldn't be changing significantly week to week. But sometimes like we had models where like every week the results looked reasonable, but from week to week, like the change was like pretty disruptive to users. So we've had to fix that too. All right, so we learned our lessons. So we set up our pipeline, we fixed our bugs, we tweaked our model, we learned our lessons, we shipped our first model, and we had stat-sig results. You might ask, is this another Figma Data Science success story in the books? And it, in fact, was not. We had statistically significantly negative results. Cool. So here comes the fourth lesson, which is patience. So from like the start of the platform work, it took us 8 months to get to our first metrics win before inbound interest started coming in earnest. And as a platform owner, having spent the last like half year sweating on this pipeline, I obviously was pretty nervous about this because you want to see like immediate adoption and like metrics wins for your platform, and you want to justify your work as quickly as possible. But the reality, and speaking to some of my peers, I hear the same, is that slow adoption or variable adoption is normal at first, especially because the demand for ML ebbs and flows with the demands of the business. And that's a good thing because that means that your company is using ML only when it's relevant to the business. Something we did do that was really helpful is we created momentum for our platform by being our own customers and building out like a multi-purpose model that we felt like a lot of different parts of our company could use in their product pretty easily. And so we took this model, we shopped it around, we really focused on the model being high quality, like everyone was really happy with the results. And also we focused on the visibility of the platform, so after this like roadshow, everyone knew that this platform was ready to use and like that ML could be a pretty promising solution. And so by the time, like before this metrics win, by the time this model hit staging, we had drummed up a lot more excitement for our platform, and everyone was just like really excited and really convinced that we would have this metrics win. And we did eventually have one. While the demand for ML in the product kind of ebbed and flowed, we found it very useful to partner with business data scientists. They often have a ton of models. They have segmentation models, leads models, forecasting models, and working with them was very helpful because they helped continue pushing like the capabilities of the platform forward. And this is also an area where investments often lead to like improvements in like metrics like ARR, and even though it can be harder to A/B test the impact of like supporting the business data scientists, I think this is an area that like generally people consider very valuable. And then finally, we collaborated closely with an engineering team on our first metrics win and eventually handed off a lot of the engineering responsibilities to that team. And so they started to take over platform investments such as scaling the platform and also moving our like custom Python job to SageMaker. And it was really helpful having this like division of labor between our two teams because that meant the data team could go back to focusing on our bread and butter, which is like modeling and finding use cases for ML. So as I mentioned earlier, we're now in a place where models are regularly productionized in our product and business. We've had some wins. And what's really incredible is that even though this impact slide, like it looks really great, like for 8 months, we just had like one stat-sig negative result and we were just kind of sweating. And so it's really interesting to see how the momentum for this platform really picked up towards the tail end of 1 year. So I hope some of our learnings and lessons were relevant to you. For us, we learned to build when the business needs it, design for predictability. We learned our 3 lessons, and we also learned that wins take a bit of time. So before we end, a few final notes. I'd like to acknowledge the great group of data scientists and engineers at Figma who worked on this platform and made this possible. And also, if you like how these slides looked, you should check out Figma's newest product, Figma Slides. It's really great. Thank you. Oh. I should. Are there any questions that I can answer? Yes.
You want me to say it, or do you want to give a mic?
I think you can say it, and then I can repeat it.
Okay,
that might be
great.
easiest.
Yeah, so I'm just curious, the role of DBT, it sounds like part of it is building the data sets, then using the predictions using Dagster. Are the predictions then going into another DBT project? Is there anything more that you're using DBT for after? Or is it just that first stage?
Yeah, so the question was around the use of DBT in this project and if we use it for anything other than generating the training and inference data. And the answer is no. Any other transformations that we did, specifically the ones that you described where we're like re-ranking like the model results or post-processing that happened in our job in Python.
Yeah, thank you.
Cool. Yes?
Great talk.
Thanks.
My question is, so DBT allows you to run Python models as well, so what was your reasoning of doing things outside of the easy workflow in Dagster versus doing it in DBT?
Gotcha. So the question was why we didn't use DBT's ability to run Python and instead chose to run Python in our Dagster job. So I'm not super informed on like the current state of running Python in DBT, but I think at the time there might have been some challenges with the packages we wanted to use, and we didn't feel like the Python was like fully set up yet. And also longer term, I think we always knew that we would want to move our custom Python code into SageMaker or like another tool that's specifically built for ML. And so I think like for V0, we just put our Python in Dagster because that's kind of where where a lot of our Python code is run. Yes?
What tooling, if any, do you use to capture the metrics and performance of the model? Do you have heard of tools like ML flow, things like that? How did you guys go about documenting improvements functions running during testing and production?
Cool. Yeah, so the question is around additional ML tooling for capturing the performance of the model as we like train over time or as like the model runs over time. And in general, you would expect like the model performance to change over time. So in our case, we didn't invest in like that tooling yet. And like part of the reason is like, I think like if you look at the first year, right? We've shipped 6 models. It's still very easy to like handle the performance of all of those models in-house. And I think there are just like kind of broader questions for our platform around like once we move to SageMaker, like what tools integrate well with SageMaker. But I just don't think we're quite at the point where we need to invest in like new tooling to track the performance of our models. But something we do which I think this happens in like Datadog right now. But like every night we do calculate like the performance of the model on the training data to make sure that like nothing like strange has happened overnight that would cause our model to degrade. Yep. Yes. Yeah, so the question is around model stability and how do you actually get your model to be more stable week over week. So I think there are like a number of things you can do. In our case, we felt like the model instability had to do with overfitting to our data set, where basically like a lot of what we were doing is we had like a classification model, and based on the output of this model, we would like rank we would rank entities by their classification score, and so that like the product use case of like ranking is a little different from like the model objective of classification. And so what we actually chose to do was to like train, like basically like train our model either on less data or shorten like the training period, because we felt like the instability and like the additional like improvement in our offline performance metric was like creating issues in our online performance. Something else you can also consider doing is like storing the results from last week, and like you can also handle like in the product, you can add like additional logic to make sure that even if your model thinks the results should all change, you only like change a few of the results. Yes?
Can I ask, if you ran into issues, time over time, with value on performance, let's say October 7th, you had good performance, and then something happened with Datadog that will let you model training and inference on October 8th, you grade it seriously. Do you have some kind of like a manual process to take that model out of the run, or not store that, or put that into like a bin or something?
Yeah, I think the way our pipeline works now is that if something in the training process indicates that our model performance has degraded, or if the pipeline just fails, we use like the previous day's predictions. And this is not going to work for a lot of use cases, but like we've mostly picked use cases where, at least in the product, like if the model fails one night, we can just use like the previous night's results. Yeah. Yes? Sorry, I can't hear very well. Do you mind speaking up?
Do you support importing other external feedback models?
Yeah, so the question is if we support importing external models. And the answer right now is we haven't needed to, so no. But the way we've set up our pipeline, it would be like very easy at this point to import like a model file. Any other questions? All right, cool. Well, thank you so much for coming.